First thing I want to tell you is today's lesson is honestly, it's going to be a little complicated. We're going to be doing some things that we did way long ago. We're going to combine them with a few little new things. So really work to try and understand what it is we're trying to accomplish here, because to be honest with you, it can be kind of difficult. We're going to be looking for some patterns, and we're going to be dealing with something that's called a function. A function is something that Mr. Boquist is going to work with a lot when you guys get to high school. Okay? And we're just kind of giving you a brief introduction to it right here and now. And so it's in your best interest to really pay close attention and try and figure out what it is we're doing. In a function, there's an input, something that goes in. Every time we put something into this function, something comes out. I like to think of it as like a math machine or something. Whatever you plug into this math machine, you're going to get something out. And inside this math machine, we have to figure out what's happening. I know it's kind of a silly way to think about it, but I think it's a good way to try and visualize it. Okay? Whatever you're plugging into this math machine, you get something else out of it, but inside this machine, something's happening. What we have to do is we have to figure out exactly what's happening. Okay? Kind of like cause and effect. Okay? So a function is a rule that relates two quantities so that each input value corresponds to exactly one output. So the way that it works is this. Your x is your input. What are you putting into the machine to get 13 out? What are you putting? You're putting 4 into the machine, you're getting 16 out. You're putting 5 into the machine, you're getting 19 out. What is it that's happening inside that machine? And it's the same thing every time. Okay? Because some of you can look at this, and we're looking for a pattern now. Some of you can look at this and go, okay, well, to go from 3 to 13, all we do is add 10. Well, if you look at this one, if you add 10 to 4, we don't get 16. You need to find the pattern. What is happening to go from 3 to 13? And then it's the same thing that happens to go from 4 to 16, the same thing to go from 5 to 19. What is our function? What is happening? And here's a hint. Usually, if your input is smaller than your output, it usually is some sort of multiplication or addition or multiplication and addition combined. What do you see happening here, Leah?
Can you change it when you go through?
Nope, it has to be the same thing. It's a pattern. Kevin. Yeah, tell me what's happening.
So it goes plus 13 is 10, and 4 plus 12 equals 16.
No. What are you doing to 3 to get 13? There you go. Times 3 plus 4. So we're taking whatever these numbers are, we're multiplying them times 3, and then we're adding 4. Times 3 plus 4. So that's my pattern. Times 3 plus 4. You see that? Because if we take 3 times 3, which is 9, plus 4 is 13. 4 times 3 is 12, plus 4 is 16. 5 times 3 is 15, plus 4 is 19. So whatever the pattern is, whatever x is, so we go x times 3 plus 4 equals y. See that? Because x and y are my variables. They can change. Now, right now, x times 3 is ugly. Let's make it pretty. What should we write? 3x. 3x plus 4 equals y. We have created a function right here. We have created this. That's exactly what we need. That answers the question. Write an equation that answers that part of the question. Write an equation for a function. So there's my equation for this function, 3x plus 4. Now, I can use any value for x. I could plug 30 into there. When x is 30, what is y? 34. So when x is 30, all we would do is we would take 30 and plug it in for x. So 3 times 30 is 90, sorry. 90 plus 4 is 94. I'm sorry, not 34. It happens. I know. This is an equation that you can plug any x value in and we can find a y. Okay? This is my machine. This is what's happening inside my machine. So for any value, anything that we find, any value of x, or any value of x, we can find a y. So what if x was 25? What is y? Alexis. $79. Because if x, let's just say x equals 25, we would plug 25 in right there. So 3 times 25 is 75, plus 4 is 79. So we could continue this chart forever, and we could always find a value for y. So when x is 10, what is y? 34. So here, that answers the other part of my question. Okay. Next. And like I said before, when all the y values are greater than the x values, usually when your input is smaller than your output, you're going to end up with usually multiplication and or addition. No. Next thing. Again, let's find the pattern so we can write an equation for this function. What is the pattern? What are we doing to x to get y? I'm going to give everyone a little bit of time here. See if they can recognize it. Go ahead, Lacey. What do you see? Sure. X times 2 plus 4. Let's test it out. 3 times 2 is? Plus 4 is? Perfect. 4 times 2 is? Plus 4 is? Well, 5 times 2 is? Plus 4 is? Okay, perfect. It works. That is it. Let's make it pretty though, because right now we have an ugly equation. Make it pretty. 2x plus 4 equals y. You can't forget that. So now, again, we have an equation. We can plug anything in for x, and we will find a y value for it. So When x is 10, what is y? 24. Because all we did is we took this 10 right there, we plugged it into x, so it's 2 times 10 plus 4 is 24. What if x was, say, 30? What would y be? $64. Very good. So we could find any value for x. If we really, really wanted to get crazy, we could say x was 6,342. We could find a y value for that. All we would have to do is plug in 6,342 times 2 and then add 4. Yes? That will not be on your quiz or anything like that. But my point is, I want you to understand that with this equation and this whole function thing, for every single x value, there is a y. And you can always find them. Yes? 12,688. I'll take your word for it. Okay? I'll take your word for it. Good. So that is going to be part of your assignment. The other part is going to have problems that look like this. You can write equations that are described in words. So, like this. This is something we did long, long, long ago. It says, write an equation for the function. Tell what each variable you use represents. Let me put it in terms that we have used this year. Make this word sentence a number sentence. Okay? We have a word sentence. We want to make it a math sentence, a number sentence. What do we have to do? Well, let's look for keywords. What are some keywords that we have here? There's some key words in this that are math words. There's some key things that we need to do. What do you see, Thomas? 7. Definitely 7. Number is usually going to go in a number sentence. Times. There's another one. Give me another one. Height. Give me another one. Width. There's one more in there. No. Jonathan. Not its. No. No. Is. Is usually means equals. Is usually means equals. If you think about it, he is smart. He equals smart. Okay? I'm telling you, you have to think with a math brain. When you come in here, you got to turn your math brain on. So we don't speak in English, we speak in math. So we have, let's change this now. We underlined all our keywords. We know what they are. So height, H, is equals 7 times W. We have, but right now it's really ugly. Let's make it pretty. H equals 7W. Now, we did the first part of the problem. Write an equation for the function. There is another part of this problem. It says tell what each variable you use represents. So we have to do that. So now this is part of the answer. The other part of the answer is you have to say that H means height and W means width. You have to do that on your homework. You have to, because it says you must tell what each variable you use. And these are all variables. Now, again, this is a function. This is an equation that we For every H value, there is a W. For every W value, there's an H. What if, let's say W is 7. What is H? 49. What if W was 10? What is H? 70. Okay. For every W value, there is an H. What do you think that, what is my, anyone want to come up and do it? Tommy Ann, why don't you give it a shot? Okay, that's the first part of the problem, though. There's 2 parts, isn't it? What's the other part? What do we have to do? Yep. Do it. Why are you so far away? Do you think it's going to blow up or what?
I don't know.
That is very fancy handwriting, too. I feel like I got to stand back, too. It's making me nervous. Very good. Remember, you need to have both parts of the problem. You have to answer the whole question, not just part of it. Because it says, tell what each variable you use represents. Very good. H equals 4W. Now, again, for every value of W, there's a corresponding value to H. What if W was 5? What's H? $20. What if W was 7? 28. Very good. What if W was 7,400,000? Never mind. No. Not gonna, because you guys, I need you to pay attention to the next problem. Now, we're going to put this together now. It says the school choir tracked the number of tickets sold and the total amount of money received. They sold each ticket for the same price. They received $80 for 20 tickets, $88 for 22, and $108 for 27 tickets. Write an equation for the function. Here's what I would do. Step number 1. First thing I would do is I would want to make a table, just like we had in the very first problems I showed you. So I would do this. I would do T, and I would do C. And I want to represent, I want to tell, first of all, I also want to say what each one of those things means. So I'm going to say that T is tickets sold, and I'm going to say C, cash made. I'm telling you, that's what it represents. T is tickets sold, C is cash made. Okay, so I got my little table here. Tickets sold. How about 20 tickets sold? What's the amount of cash made? 80. Then it says 22 tickets sold. What is the cash made? 88. And then we got 20. Oh, sorry. Yeah, 88. 27 tickets sold, and we got 108. Okay. Now, the question is, write an equation for the function. We need to write an equation. We need to figure out what, this is just like X and Y. What are we doing to this to get that? Tell me, Ann. Times 4. Let's see if it works. What about 22 times 4? What is 22 times 4? 88, so it works there. 27 times 4 is 108. Remember, it has to be the same thing every time. So it is times 4. So what is my equation going to look like? Good. Good. All right, now, enough with the smiley faces. Let's pay attention to the math portion of this. These are funny. C equals 4t. Again, for every single corresponding, for every single t value, there's a corresponding c value. What if t was, again, what if t was 5? What is c? 20. So now we have this thing. We can plug it into anything. Now let's say I run the school choir, and I know that I need to make $150. Using this equation, can I then figure out how many tickets I have to sell in order to make that $150? Absolutely. I could plug 150 in here equals 4t, and again, you know how to solve that problem, don't you? With our algebra rules. Remember our algebra rules? What's the rule number 1 of algebra? Oh my gosh, come on, we've done this a gazillion times this year. Rule number 1 of algebra. Figure out what's happening to the variable and do the opposite. Rule number 2. Do rule number 2. You have to do it to both sides. Okay. So, what's happening to the variable and what's happening to the variable in the situation? It's being multiplied by t is the variable. It's being multiplied by 4. Good. Woo! And the exact opposite of multiplying by 4 is? 5. So we divide by 4 here. We divide by 4 here. Tickets sold that we need to have is going to be 150 divided by 4, which is? Stop guessing. 37.5. Can you sell half a ticket? Hey, focus. Back with me. 37.5. Can you sell half a ticket? So how many tickets do they have to sell in order to make $150? 38. They gotta sell one more. Okay. I know I took this another step, which I did, because I figured you guys could handle it. I wanted you to understand that you can work these equations both ways, and you can use this equation to find out information. What you are going to be asked to do for your homework just for today is this. Write an equation for the function. So once we found the equation, that's all you're going to have to do. But I did take it a step further because I wanted you guys to understand that that is the sort of thing that you're going to do in the future. We're going to move on. Yes? You do have to show what each thing represents. You should. It'll help. Yes, that would be best. Now, just flip over your homework or do something. Find a sheet of paper in your folder that is blank, so you have enough room. I want you guys to try and solve this one. Write an equation for this function. There's your equation. 3t equals c, or whatever variables you chose. But you have to do this. You have to tell me, what does T equal? Equals tickets sold, and C equals cash made. Okay? Homework. I want you to do page 642, 6 to 18 even. This will be due tomorrow. Even though we have Washera Olympics tomorrow, you still have math class in the morning. Shara Olympics.